short-term training program organized by Panimalar Engineering College in the Department of Artificial Intelligence and Data Science. We are honored to have such a distinct gather academician, research and experts, all united by a shared commitment to continuous learning and professional growth. The field of education is ever evolving. As a educator, it is vital that we keep pace with the changes not only in terms of content but also in the methodology, technology, integration, and the student encouragement. This short-term training program aims to provide a platform to explore innovative teaching methodologies, share best practice, and foster interdisciplinary collaboration. So I sincerely hope that this section over the coming days will be fruitful. So throughout provoking all about expressing, may this Sttp new ideas and deepen your passion for teaching and learning. So once again, I welcoming today our esteemed research person, Dr. Sivakandan, Associate Professor, the Department of Advanced Computing, St. Joseph University from Bangalore. So now I call upon Mrs. Ranjita ma'am to give the brief introduction about our resource person.
A very good morning to everyone. Welcome you all for the Day 6 STTP online program. Today our resource person is Dr. Shivakannan. Yes, we welcome you, sir. Dr. Shivakannan is a seasoned academician and researcher with over 13 years of experience in teaching, research, and academic leadership. He earned his PhD in image processing in 2018 and specializes in artificial intelligence, medical image analysis, and healthcare data analytics. He currently serves as the Associate Professor, IEEE Branch Counselor, and President of the Institution Innovation Council and St. Joseph University, Bangalore. And collaboration within the academic ecosystem. Dr. Shivakannan has successfully organized and led faculty development program and student research initiatives. Notably, he received funding from AICT, translate complex AI concepts into impactable healthcare solution, has made him a sought after mentor and speaker. Dr. Shivakannan has published widely in reputed national and international journals, presented at leading conferences, and actively engages in technology summits, STP, and innovation forums. His passion for education, innovation, and applied research continues to inspire students and fellow education alike. Once again, we welcome you, sir, for the 6th day online STP program. Thank you, sir.
Thank you, ma'am.
Thank you, ma'am. So now, I once again I welcome you, Dr. Shivakannan. So today topic he covered the tools and frameworks for healthcare data analytics. So once again I welcome you, sir. Now session for you. Share the screen, sir.
Yeah, I'll share.
Yes, visible, sir. Full screen.
Is it visible?
Yes, sir. Yes.
Okay. So good morning, Mananda. First of all, I want to thank Dr. Jnana Prakasham from Panimalar Engineering College, and I want to thank HOD and management from Panimalar Engineering College. So today my topic is tools and frameworks for healthcare data analytics. So first, what I'm going to do is what research we are doing now, presently now, what is our future work, and after that, I'm going to show one demo using Rapid Miner tool. I don't know how many people have used Rapid Miner tool. So it's a AI tool. So that demo I will show using medical data. So this is what I'm going to cover today. And so what we are doing is diagnosis of aortic stenosis. I don't know how many people know about aortic stenosis. So we are going to predict the aortic stenosis using machine learning and deep learning techniques. This is what we are doing presently. So we have done 3 works already and we have published. And also we have used only one signal data, that is ECG. So there are many data we can add. So in future we are going to integrate all different data and we are going to optimize the deep learning or machine learning algorithm to get better prediction output. So this is what we are going to do. That is our future plan. And what we have done is we have already implemented few algorithms and we have used only ECG signal now. So we are planning to use some more signals, some more data for prediction of aortic stenosis. So you should know what is aortic stenosis and why we have used ECG signal. So I will tell about some short introduction. So this aortic stenosis is one of the cardiovascular disease. So we have many types of cardiovascular disease. So why we have taken this topic is around 52% of men are getting cardiovascular disease and 39% of women are getting cardiovascular disease. If you are seeing other problems, the percentage is very less. If you are seeing prostate cancer, it is only 60%, 16%. Breast cancer is only 12%. Lung cancer is 8% and 6%. This is colon cancer. Colon cancer, both men and women are getting only 5%. So nowadays, all are getting heart attack and cardiac arrest. So all those problems they are facing. But we have some. There are many types of cardiovascular disease. You can see here. So this is one type of cardiovascular disease. Inside the vein, some fatty deposits are there. Here you can see. This is one of the coronary artery disease, and this is for heart failure. Here you can see. So many
Sir,
doctors will
sorry for
tell
the
heart. Yeah.
interruption.
Yes,
Your
sir.
slides not moving, sir. Now moving.
It is moving.
Uh,
Moving, sir.
yes, yes. Right, so okay, sir.
Is it visible? Now types of heart diseases here.
Okay.
Is it visible?
Yes, sir.
Nanoprograms. Yeah,
Yes, sir.
okay.
Yes.
So this is one type of cardiovascular disease. You can see here fatty deposits are there. So for this only, many are doing surgeries, angioplasty, all those surgeries they will do. So second, if you are seeing heart failure, so doctors will tell some hole is there in the heart. That means here you can see. So this is called actually dilated ventricle technically. So third one is, if you are seeing here, this is a ventricle. So here inflammation will be there. Because of that, people will get the problem. So fourth one is cardio myopathy. So here, this space, you can see the difference between this and this. Here, more in the ventricle space is very less. So this is also another problem. And disorganized electrical signal here. See here, you can see two nodes. This is SA node and this is AS node. So this is a natural pacemaker in our heart. So it will give the electrical signal. So this signal only we are measuring using ECG. So that I will explain. So here disorganized electrical signal. So that normal signal we won't get. So this is also called one type of heart problem. And this here, this is actually a vein. So here some swelling is there. And finally, we have two valves in the heart. Two valves in the heart. One is one of the valve is aortic valve. Here in the right side, we will be having pulmonary valve. Left side, we will be having aortic. So aortic valve, if the valve is having some problem, then it is called stenosis. So here in the left side, we will be having aortic wall. So in the aortic wall, if you are having any problem, then it is called aortic stenosis. So you can see the normal valve and uh, so the wall with some problem. So you can see here. So we in our research we are concentrating only on these aortic valve, the left side, not in the right side. So many people are doing research. They are doing research only for general cardiac disease. So that will not point out the problem. So we analyzed a lot of types, and we have found that this is one of the booming research for cardiovascular disease. So we can either use pulmonary valve or we can use aortic valve. So many are getting in the US around 75 million people are getting this aortic stenosis after the age of 75. So we have selected this aortic valve for our research. So these are all the types. So we are concentrating only on the valve. So there are two valves. One is pulmonary valve and another one is aortic valve. So I want to explain what are the risk factors for this cardiovascular disease. One is smoking, then high blood pressure, high cholesterol, diabetes, and physical inactivity. These are all the risk factors, uh, and obesity and unhealthy diet. So now I want to explain about this aortic stenosis. So aortic stenosis is a life-threatening cardiovascular condition marked by the constriction of the aortic valve opening. So I want instead of reading, I will explain here. So this is the heart anatomy. So if you are seeing here, here atrium is there, here ventricle will be there. So this is right atrium and right ventricle, and this is left atrium and left ventricle. So if you are seeing, so oxygen-rich blood will come from right atrium here. So here SA node will be there. As I told you, it's a natural pacemaker. It will give the signal. After giving the signal, this atrium will eject the blood, oxygen-rich blood to this right ventricle. So then again, it will give the signal to here, to these nerves. These nerves signal only we are reading using ECG signal. So from here, one node will be there, here another node will be there. So it will give the signal. So if this SA node is having some problem, then we have to place the artificial pacemaker. So here, after giving the signal, this oxygen-rich blood will go to here. Then this is called pulmonary valve, and this is called aortic valve. So then again, it will go to the left side. So again, it will go to the left atrium, and again, it will go to the left ventricle. From left ventricle to this atrium wall, it will go to the body. So this is the function this heart is doing. It will get the oxygen-rich blood from right side, and it will give it to the right ventricle, and from right ventricle, it will give it to the left side atrium. From left side atrium, it will give it to the left ventricle. From this wall, uh, aortic wall, it will give the blood to the body. So this pulmonary wall is sending the blood from this right ventricle to left atrium. This aortic wall will send the blood from left ventricle to the body. So this is what is happening. So here these two walls are important. So in our research, we have used this aortic wall, this one. So what are the problems we may face the aortic stenosis? So here, if you are saying, so this is the wall. Actually, so if you are saying it has to open like this. So I already shown So actually valve will be like this. If the blood is flowing, then it will open. And again, it has to close it. Okay. So if you're saying this is a normal one, if if the valve is like this, then this is also a problem. It is not closed properly. First of all, it is not closed properly. Here you can see it is closed properly. One more thing is there, because of calcium deposit, it will not open properly. Even though if it is normal, because of calcium deposit, it will not open properly. So these are the problems we will be facing. So when we are getting these kind of problems, see here, actually, this is the diameter. We should have this much diameter in this wall. Actually, three doors will be there
Sorry, sir.
like this.
Slides not moving.
Again, sir. What about now, sir?
Now it's moving, sir. You go for the slide view, sir. Full screen.
How it is changing?
No, no, no.
It's not
Only
changing.
not moving. The introduction is moving, but you can go for the presentation, sir.
What about now? I'll share again.
Okay.
What about now?
Okay, sir. Okay, okay. Now,
So you can see the valves here. This is a normal valve, and this is the valve with stenosis. So it is closed properly, but this valve is not closed properly. This is one type of problem, and another type of problem is it will close properly, but uh, calcium deposit will be there. So if the calcium deposit is there, then this thin skin cannot go inside because thickness is increased. So if thickness is increasing, then it cannot open the wall properly, so that the whole size will be very small. So because of that, we will be getting more blood pressure. So these problems we will face. So what are the types of problems are there that we need to see? You can see here in this. This is with no stenosis. So all three doors are there, but it is opening properly because of this calcium deposit. It is not the diameter is reduced. Here you can see this is a moderate stenosis, but here this is a severe stenosis. It is opening, but the hole size is very less. Okay, so if the hole size is very less, what will happen? So actually, from the left ventricle, it has to pump the blood to the body. So if it is normal, it will flow properly. If the size is reduced, then what will happen is the flow will increase. So it has to give more pressure. Actually, heart has to give the more pressure to pump the blood to the body through this valve. So that is one problem. Second problem is because of that we will get what is that? Here, the hole is very less, but the pumping is more. Because of that, we will get faint if the stenosis is severe. So, what doctors are doing is they're putting stent. That is one type of thing. Another one is artificial valve they are fitting. Uh, I will show you the artificial valve first, then I will come to what are the types are there. You can see this is artificial mechanical valve they are fitting. So it is a kind of tissue valve. It will open and close. So whenever the blood is flowing from left ventricle to the body, it will open. After that, it will close. So what are the types of stenosis are there? So first type is this congenital or aortic stenosis. in this time, by birth itself, they will be having problem. What kind of problem they will be having? So instead of three doors, you can see here, three doors are there. One, two, three. Instead of three, only two will be there. So only two skin will open instead of one skin. So that will reduce the size of the wound. So next is degenerative aortic stenosis. Over the age around after 70, 75, they will be getting aortic stenosis because of calcium deposit. So third one is rheumatic aortic stenosis. This will happen because of high fever or some other viral infection. So these are the symptoms. Chest pain we will get, then shortness of breath, fainting, fatigue, heart murmur, palpitations. All these things are the symptoms for aortic stenosis. So, but if you are having these symptoms, we can tell it's a heart problem. We cannot exactly tell it's aortic stenosis because many uh, cardiovascular diseases are there. So these are all the symptoms. Based on that, we can't come for the conclusion. So we have to uh, do the diagnosis using the data. So the diagnosis we can do by meeting the physician, and second is echocardiography ECG, echocardiography. Third one is electrocardiogram ECG. Fourth is X-ray we can take, and fifth is cardiac catheterization, and finally we can use CT scan or MRI scan. So in our research, what we are using is we have used only ECG, but we are planning to include data from physician and CT scan. X-ray we are not going to consider. It is not giving good accuracy from our literature review. So we are going to we are going to consider computer tomography and MRI scan with along with this ECG. Now we have done our research only with ECG. So what are the treatments are there? That this is the treatment for aortic stenosis. We can fit aortic artificial valve. And now presently, doctors are using transcatheter aortic valve placement and balloon valvuloplasty. So inside the valve, they will put some balloon kind of thing, and it will increase the size of the valve. And we have to uh, eat healthy food that will come under lifestyle modification. So why we have considered ECG data for aortic stenosis? As I told you here, this is the SA node, this is the atria, this is ventricles, two ventricles are there. So here SA node will give the signals to here. So after getting the signals from here, this atria will eject the blood to the ventricles. So through here, it will give the signal, and again it will give back the blood to the left atria, and again it will come to here, and again uh, the left ventricle is giving the blood to the body through this aortic stenosis. So through ECG, how we can find us? So if it is giving signal, you can see here. If it is giving signal, it will give the P wave. It will give the P wave. So from ventricles, if it is pumping the blood through these valves, we will get PQRST. So this is PQRST. You can see this is QRS. This from here it is T wave. Okay, so if the spike is more, that means some pumping problem is there. So this is what we found from the literature survey. So we have considered ECG right now. So we are going to include CT and MRI also. So I think you have you understood. So again, I'm telling here this SA node is giving. This is a natural pacemaker. It will give the electrical signal to the heart. So through this only we are taking the ECG. So from here, after getting the oxygen-rich blood, it has to give the signal to here. After giving to this node, the blood will go to the ventricles. Then again, the signal will go to here and here. It will split into two signals. It will go to this side and this side. Then again, it will pump the blood to the left side, and again through aortic valve, it will go to the body. Okay, so because of this only, we are getting that locked up sound. So here, we are going to consider this only QRS wave. We are going to consider only this QRS wave. If the spike is more, that means some pumping problem is there. So through this, we have got features. I will tell you what are the features we have got. You can see here the site of stenosis typically shows specific abnormalities in the electrocardiogram due to pressure overload. As I told you, if the hole size is very less or uh, that valve became very thick, it cannot open. So because of that, pressure will be more. If the pressure is more, then QRS wave will get high voltage. So you can see manifesting as high QRS voltage. High QRS voltage means the spike will be more. The spike is more, that means some pumping problem is there. So this is what we found from ECG data. So these are all the important features from ECG data. So as I told you, QRS complex duration, how much duration it is taking, then QRS axis, then R and S ratio, then segment deviation, ST segment deviation, T wave inversion, then heart rate variability, then P wave morphology. These are all the important features we extracted from the ECG signal. So these are all the literature reviews we have done. So you can see here they have got 94%, 96%, but we did not get 94 or 96. We have got 87% maximum using uh, using ECG data. You can ask why we have got less compared to the literature survey. It is because of the number of samples, and we have used real-time data. We have got some of the data are real-time data. We have MOU, so we have got data from hospitals, and we have trained. We have done some few trial and error methods. So one of the trial and error method is we have trained the model using uh, existing data, and we have tested our model using real-time data. So because of that, we have got less result. And initially, we have done. We did not use any algorithms for feature extraction and other things, but after that, we have used many algorithms for feature extraction, filters we have used. So we properly extracted the data. So because of that, we have increased the accuracy, but we did not get this much accuracy because of number of samples. If number of sample is more, then you will get less accuracy. If you're having less number of samples, you will get more accuracy. So because of that, they have got this much accuracy. So our data set is different. So because of that, we have got less accuracy compared to this. But if you are seeing this, here they also got 73.77 and 86.21% of results. So these people did not specifically uh, uh, predicted for, especially for aortic stenosis, but we have concentrated only on aortic stenosis. So they have done only for cardiovascular disease. It's a general cardiovascular disease. So we have narrowed down to aortic stenosis. So these are all the literature surveys we have done. So what are the challenges we addressed is, so heart wall replacement is very difficult. So because of that, if you're diagnosing the problem earlier, you can reduce the calcium deposit into the wall. So that is uh, one kind of thing we addressed from the doctors. So what they told us, uh, if you are detecting in early stages, we can reduce the calcium deposit in the wall. Then symptoms from I already told three types of problems, three types of aortic stenosis is there. The first type is by birth itself they will get. So instead of three gates, only two gates will be there. So for that we can do the surgery, but many will not bother about that in their childhoods because children will be getting some uh, fainting, something will happen to the children. So we won't much bother about that. Because of that, in future, they will get after 10, 15 years, they will get severe problem in aortic valves. Then we can't conclude with only one uh, data. Uh, ECG data. So as I told you, we are using ECG, but we need to include doctors' advice and also CT scan and MRI. So till now we have done using one data set. So this is the first research we have done. So here also we have used same ECG and random forest, K nearest neighbor, gradient boosting, and artificial neural networks. These are all the algorithms we have used. In this, what we have done is we have converted signal into tabular data and we have used these supervised learning algorithms. So in this study, we have used 19,140 ECG signals. And from these 19,140 ECG signals from 9,000 patients, you may ask why 9,000 patients are there and ECG signal is 19,140. We have taken multiple ECG signal in different time with the same patients. So morning one, afternoon one, night one. Like that we have taken and we have analyzed. So, and also as I told you, existing data also we have used. So this is the source, MIC. Around 8 lakh ECG data were there from 1 lakh 60,000 patients. And in this, you can see around 19,000 I thought. So around 6,000 is a normal uh, sample. That means without aortic stenosis. This atrial flutter is another problem. Atrial flutter is another problem. It is not aortic wall problem. So around 3,881, we had aortic wall problem, and around 3,204 ECG signals had anteroseptal intract problem. So these are the four problems we have taken and we have trained the model. So from we have given very less number of samples compared to this atrial flutter because we did not get much number of data only for atrial valve. So we have taken ECG signal, then we have used discrete wavelet transform for feature extraction. So we have taken only low frequency component from DWT. So as I told you first, we have considered only QRS data from the ECG signal. After that, we have extracted the features and we have used these four algorithms and we have done the performance analysis. In this, we have used a signal filtering, baseline noise removal, feature extraction, and Q waves, S waves, all these things we have used. As I told you, we have used four algorithms. So in the second work also we have used the ECG signal. So in this, we have considered around 10,646 patient records. And in this, we have considered 45,152 patient ECG. And we have used different algorithms here. You can see here. So this is the input signal. So we have used different filters uh, for noise removal, and again for feature extraction we have used wavelet transform. As I told you, we have considered only QRS data from the ECG signal. Then again, model development. Here we have added more number of models. So the differences you can see here. Here we have used notch filter, adaptive filters that we did not use in the previous one. And so many researchers, what they will do is uh, they are removing the noise in the signal. They will directly use the algorithms for model. So we have used different filters and different transforms uh, for feature extraction and noise removal. And these are all algorithms we have used in the second work. So we have added CNN, LSTM, and CNN, RNN, LSTM. These are all the hybrid models we have added, and we have evaluated the performance. So as I told you, extraction of ECG features related to aortic stenosis is in the left side. So QRS duration and amplitude we have calculated. These are the features actually for finding aortic stenosis. This QRS is very important in ECG. And in this method, we have used a hybrid CNN, RNN, LSTM model for the same ECG dataset. And we have compared the output with different algorithms. But you can see the difference. First, what we have done is after getting the after extracting the features, we have given the same data to all the algorithms, and we have checked the performance for each algorithms. Then this is our third one. So here we have done one more hybrid algorithm. This is deep ECGNet. This is readily available, and it is designed only for detection of aortic stenosis from ECG signal. So here we have taken only 500 samples, only normal and abnormal. Because if you're seeing existing two algorithms, we have four classes. Here we have taken only two classes. So only normal and abnormal means abnormal with aortic stenosis. So this is the flow diagram for detection of aortic stenosis. So here I have changed the noise removal algorithm. Instead of filter, we have used thresholding method, and segmentation method we have used, and Shearlet transform we have used, and we have split it into male and female separately, and deep ECGNet we have used for aortic stenosis, and we have optimized the algorithm. This we did not use in the previous algorithm. Then we have compared the results with all other algorithms. So this is our third work. With this, we have stopped. Now we are planning to add CT scan and MRI with this. So these are the results we have got. I will show you the comparison. So for some using support vector machine, we have got only 74% accuracy. One pending workers in this, if you are seeing, we did not come after this part. We have used only deep ECG net. In this work also, we need to compare with other algorithms, and we need to compare the accuracy of the model. That is pending in this work, and in future we are planning to add CT scan and MRI scan. If you're seeing SVM is giving 74% accuracy, random forest is giving 76, CNN alone is giving 80%, LSTM alone is giving 82%, CNN LSTM hybrid model is giving 85%. and CNN, RNN, and LSTM. The existing work it is giving 87%. These are all the comparisons we have done. These are the references for any question from your side. Now I can go for the demo. If you have any questions, you can answer.
Participants, any questions? No questions, sir. You can further continue.
No questions? How can I take, sir? Okay. Yes, sir. I have used only ECG. In future, we are planning to add CT scan and MRI. So it's a healthcare data. It is very difficult to get the healthcare data. Even if you are getting data, also we are getting less number of samples. So that is a problem. So if you are having MOU with one hospital, yes, the patient who is coming only for this aortic stenosis is very less. So we are getting very less number of data. So from ECG signal only, we have to label the data and we have to analyze it. Any other question?
Good morning, sir.
Yes, sir.
I'm Tamilian from Deltec University.
Yes, sir.
Very good presentation, sir. But the RNN is very suitable for time series data. You are using objective 3, three in RNN.
Sir, actually, in the ECG, we have to calculate both time and amplitude in QRS. So it will be in the graph sheet. If you're seeing the ECG signal, it will be in the graph sheet. So we have considered time series data from the third work.
Sir, what about the other two, sir? The objective 1 and 2 also time series data or some images only, sir?
Sir, we have that is images. Sir. So we have only the spike.
Thank you, sir.
Sir, how can we get the real-time data for healthcare?
Sir, now many companies are working for collecting the data. They are doing as a paid service. So they are going and collecting all medical related data, but the problem is ethical issues are there. So they should not reveal the patient information. So many hospitals are not giving the data. So in India, it's very difficult to get the digital data. So uh, if you are going and collecting the data from the hospital, they will give the ECG in paper. What is that in graph sheet they will give you. If you're scanning, it will convert it to image data. You can't get the signal data. So different kind of data you will get. So it's very difficult to what to say. It's very so these are all the difficulties here. So they're not easily giving the data to us. So we as a university we should have some MOU with some hospitals, and mutually we have to collect the data. And that particular hospital should have more number of patients. Then only you can collect the data for your particular problem. I think I answered for your question. Sorry, you're not audible.
Vidya ma'am?
Yes, sir.
You got the answer, ma'am?
Yes, sir. Thank you, sir. Thank you, sir.
Okay, ma'am. Okay, sir. You can continue your demo.
Okay. Okay. So actually, I'm going to introduce a new tool. I don't know how many people know about this Rapid Miner. So last 2 years, I have used Azure ML Studio. So now it became paid version. So we need to pay money after 1 month. They're giving only 1 month free period. So after that, we need to pay the money. So presently I'm not using Azure ML Studio. So now Azure ML Studio is converted to Azure Machine Learning. You can see. So nowadays we don't have to write the program for it. So already optimized algorithm they have designed. So only we need to feed the data to the tool. So automatically you don't have to do anything. This is a kind of AI tool. This AI tool will take your data. If you need any data pre-processing, this tool itself will do. Then you have to manually select what are the data, what are the attributes you need for prediction, what are the dependent variable, which dependent variable you should choose, and what are the independent variables uh, we need for prediction. All those things you have to select. So I will share my screen. You can. So actually, this is the Rapid Miner Studio. So you can go to this website. The website is Altair website. So here you can go to the products. Here many products are there. AI powered engineering, data analytics, and AI. So I'm presently using this data analytics and AI. Okay. So here, this product we can use it for prediction. Any prediction you can do. So I'm using trial now. I'm using trial now. You can download this. For cloud also, Altair AI Cloud is there. My screen is visible.
Yes, sir. Visible.
Visible, sir. Visible.
Yeah, you can see here. So what you can do is you can download this AI analytics. So many are there, AI Studio, many are there. So I will show you. So it will be like this. So after downloading, it will be like this. So here you can open. Here already depository will be there. You can open the sample. You can see already. So you can open the blank process also. I will start from the beginning, then you will understand. So this is the design. It will be blank actually. So after opening, you first download it and install it. You have to give your official mail ID. Then only it will be downloaded. Then they will give the trial period for 1 year. 1 year trial period they will give, but they have restricted many algorithms. But if you are giving your official mail ID and if you are submitting your ID card, they are giving all the access for 1 year. After 1 year, you have to pay. So within this 1 year, you try to complete your research. So here you can import the data directly. Directly you can import the data. So I'm showing you only the tabular data now. So from database also you can connect the data. From my computer, you can select the data. So I already imported the data here. So this is one of the data set. You can see this is the data set I have imported. In Python, we have to do statistical analysis. Everything separately we need to do. Here, if you are clicking, this tool itself will find all the statistical analysis and it will give the answers. You can see here. You can do the visualization also. So what is the age and what is the obesity? So if you want to plot it, you can directly plot. You can change the plot type also. Many plot types are there. So we don't have to use visualization tools like Tableau or Power BI. So directly we can do it here itself. And this attribute is having some problem that we can change it. Then if you are going to auto model, you can see I already got the result. I will start from the beginning again. So I have selected the data set. So here it will ask whether you want to predict or you want to cluster it or you want to find only the outliers from it. So if you want to predict, you can click predict. Directly you can do the prediction. Then what are the algorithms you have to use? That also click on the data of the column you want to predict. Which column you want to predict? So this level is the dependent variable. So I'm clicking this. So I want to predict this is the tabular data. These many are there. I did not do anything. I did not do any feature extraction. This tool itself will do all the feature extraction. So what I have done is I need to tell what I'm going to do. So whether I need to predict or cluster it. So I'm going to predict it. After clicking this predict, we can directly select the output variable. So this is the output variable. You can click next. Okay, so in the output variable, there are three categories: high, medium, and low. So there are 365 samples are there in high, and 332 samples are there in medium, and 303 samples are there in low. So almost all are equal. All the classes are equal. So I can go to the next one. So what are the inputs you can select? So here, red color they have already given because they already done the statistical survey. So in this correlation is very less. That is why it is showing red color. So these are all yellow colors and green colors. Green colors are having more correlation. So without checking anything, without writing the code, it is giving all the things. So if it is red, that means there is no correlation. So this tool itself, it did not select the particular column. But if you want to select, you can select. So I'm not going to select. Then next. So what are the models you want to train? So here by default it's a trial software. So in this naive Bayes is there, logistic regression, deep learning ANN is there, random forest is there, gradient boost trees are there, supported. These many algorithms are available in this trial version. So if you want to select, you can select. Otherwise, you can deselect and directly you can run. So here you will get the. I have selected almost all the algorithms. You will get the result for it. It is running. Then you can directly export the output and you can use it for your research paper. one by one you will get the output. You can try. See, for naive Bayes, it is showing the error. If you want error for your research paper, you can select the error or you can select the accuracy here. So 92% accuracy naive Bayes algorithm got. So here you will be getting the training time, everything you will get. If your data is not good, then it will take more time. If data is good, then it will take less time. Here you can get the training timing also, scoring time, everything, total time, everything you'll get. So directly you can export this output and you can use it for your research paper. I did not explain explain you the data set. I'll explain now. So actually, this is a cancer data set. You can see it's a tabular data. In this, patient ID, age, gender, air pollution, alcohol use, dust allergy, occupation. These are the columns. It's a clean data set. You can see. What is the level of the cancer? These three classes are there. So if you are using unclean data set or with more number of missing values, it will take more time. For filling missing value also, this will do automatically. You don't have to do anything. If it is continuous variable, it will check both mean and median, and whichever, if there is no layer, then it will use median, or otherwise it will use mean. So now we got result for all the algorithms. You can export. You can export as a CSV file, anything. You can save somewhere. This also you can save as a PNG. You can use it for your research, this comparison research. So you can try this Alter, this rapid miner from Alter website. You can complete your research in few minutes, but if you are developing a new algorithm like hybrid algorithm, you can't use it. But if you are using any existing algorithm, you can directly use this rapid miner instead of Python. So here it is giving optimized result. We have written the Python code and we have checked the output, but it is giving less accuracy because optimization is not good when we are writing the program. But this tool is giving good accuracy. You can try with Azure machine learning also, but it's a paid version. You can try. So there, the flow, what you in Azure machine learning, what you need to do is you have to grab all the blocks. So for example, if data set, if you want to import data set on block will be there, you have to drag and drop. And in that block, you have to import the data. Then what is the next step? So for pre-processing, what is the pre-processing we can do? Then train test split, then model. Everything will be there as a block. You have to drag and drop. But in this rapid miner, nothing is there. It will do by itself. But you can consider only for existing algorithm like maze bias, logistic regression, SVM, decision tree. For these things, if you want to use, you can use this rapid miner. Otherwise, you don't have to use it. So this is a demo. If you want more demo, I will show you from this. If you want to know how to download it, I will show you how to download it. Here, so many are there. You can see so many products are there in this. All free only. You can use it. So this is rapid miner. This is what I have used. Alter rapid miner. You can download it. You can go to this website, you go to rapid miner and you can download, but you have to give the, you can see, you have to create an account. You give a commercial purpose, in educational purpose, it is not coming. Here you give your role as assistant or associate or professor. You give your official mail ID, then you will get it. So I will show you. Yesterday I downloaded this AI Studio. You can download, you can see. Then you can install, then you will get this window. Okay, so all are auto models. You can get the output. Any doubts in this?
So images can use this rapid miner.
This images you can use, sir. So save as PNG. You can save it anywhere. Desktop I'm saving.
Input images, input data like images. How can we use that?
Which one, sir?
Input data like images. Example,
Okay.
MRI.
Sir, actually, yeah, correct. It's a trial one. So I could not import the image. So I need to give my ID card. My account is over. Then I need to buy. So what you can do is you can use, if you have two official IDs, you can use both. One by one you can use in your research group. One by one you can use. First you can use your ID, you can use it for 1 year. Then you can ask some other's ID. And without knowing, I have used my ID. So now yesterday I'm opening, it's not working. So again, I gave another ID to get this. So it will take minimum 3 to 4 days to get the licensed version for 1 year. So you have to upload your ID card also. So this is a new tool you can teach to your students also for doing their project. So here deployment, everything is there. If you have any doubts, you can ask. If you have any questions, you can ask. I will share my.
Good morning, sir. If a paid version means how much amount we have to pay, sir, per year?
Sir, for institutional purpose, it is very less only.
Oh,
Around $1,000 they asked in Azure. We have used at free of cost. It is very easy to use. We don't have to write the program in Python. Nowadays, nobody is writing program in Python. So now for writing, what is that? For train the model, again they are using AI model. So actually, this is a AI tool. This is a AI tool. It will find the best statistical method. It will find the features from the input. It is only finding the algorithms. So nowadays nobody is using Python code, but now we are teaching Python only, Python and R. But in software companies, they are using different tools. But only for the interview sake, they are asking questions from Python now. So in few years, it will change. So we don't have to train the model. AI itself will train the model for the new data set. So around $1,000 you have to pay.
What?
If it is institution, then it is less. But for first 1 year they are giving, so that if you start using that, then you will recommend that product for your syllabus. So anyway, you will buy. So because of that, they are giving software for 1 year. This is my email ID. You can contact anytime. This is my phone number.
Dear participants, if you have any questions, please raise. Okay. So we are not receiving any questions, sir. So now the session will be closing. So thank you, sir. Thank you for your valuable information sharing with us and how simply doing the uh, project using AI tool. So once again, I thank you. So accept my invitation and presenting your views of projects and all those things. Thank you, sir. Now,
Thank you, sir.
thank you, sir.
Thank you, everyone.
Okay. Now you can leave the session. Dear participants, um, 11 o'clock, the corresponding short-term training program test will be sharing the Google Form link. So please attend the test and complete the test within the 1 o'clock. So we have the validatory function at 2 o'clock. So all the participants can join at 2 o'clock. Thank you. Now you can leave the session. Thank you.